we're going to be covering topic 3, which is matter flow in an ecosystem. Now, by the end of today's lesson, you should be able to analyze the movement of matter and energy through carbon, nitrogen, and water cycles. Collectively, we refer to these cycles as the biogeochemical cycles. So we've already learned about the fact that energy is able to flow through an ecosystem, and it kind of moves from one trophic level to the next. And as we move through these trophic levels, the amount of energy available decreases because we said that some of that energy gets used by the organism just to kind of stay alive, to grow, to develop, to undergo things like cellular respiration, reproduce, etc. And then obviously some of that energy also gets lost as heat. So all that's left is 10% of the original energy that organism has. And that is the amount of energy that's going to be moving on to the next trophic level. In addition to energy movement, matter also exists in our universe, okay, in our planet. And matter is also something that moves in an ecosystem, or gets cycled in an ecosystem. So definition of matter is anything that has mass and takes up space, all right? So air is an example of matter. Anything solid that you see around you, including our own bodies, made from matter. Anything liquid is also made from matter. So that's why we say the 3 states of matter are solid, liquid, and gas. The only thing that is not considered matter is energy. And that's why we're looking at both of these things as separate entities, right? We first looked at energy transfer. Now we're going to be looking at matter transfer, because matter and energy are not the same thing. Remember that an ecosystem is made from 2 parts, biotic or living parts, and abiotic or non-living parts. So matter is going to be cycling through the ecosystem between these biotic and abiotic parts of the ecosystem. So what are living things actually made of? So if we break down any living organism, we will see that it is any living organism is made from elements, all right? And we said, if you remember from chapter 2, the most common elements in all living things are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And if you remember from chapter 2, when we talked about the carbon-based molecules, the macromolecules that are found in our food, but they're also found in our body, and they're kind of like the building blocks of everything in our bodies. Those are made from, those consist of different elements, mainly, again, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And they come together, these elements, you can think of them as Lego blocks, right? So each one is a Lego block, and they come together to build different molecules, whether it be a protein or a lipid or a carbohydrate, etc. They're made from these different elements put together. And then collectively, all of these large molecules make up our bodies. They compose a living thing. So once a living thing dies and their body decomposes, guess where these matter particles return back to? Where do these elements return back to? The carbon, the hydrogen, the nitrogen, the oxygen, etc. They all return back to the soil, where they are then used by other organisms, including plants, bacteria, whatever, and it's kind of like a cycle that just is continuous. Now, why do we need a cycle? How come with energy it seems like it's a linear transfer, okay? When it comes to energy, it seems like it moves in one direction, right? It moves from the sun, right? The sun is the main source of energy. It's the first source of energy. Without the sun, we would not be able to exist here, because the sun is the main source of energy, right? So the sun, some of that energy from the sun gets used by producers such as plants, and these producers are going to use photosynthesis to harness the sun's energy in order to make sugar, which is usually like glucose, let's say, which is a carbohydrate, right? So carbohydrate, we know, contains carbon and hydrogen, maybe oxygen, all right? So these elements that were used to make glucose essentially have energy stored within them, all right? And then when let's say like a rabbit, a herbivore, a consumer, comes and feeds on the plant, they gain 10% of that energy. Let's say a fox feeds on the rabbit, they get 10% of that remaining energy, and so on. So the energy is moving through a food chain okay? And we use those arrows to represent the movement of the energy from one organism to the next to the next. Linear. Eventually, the energy, as we move up trophic levels, we said that the energy kind of decreases, right? It keeps decreasing, until you don't have enough energy to sustain another level. And that's why you usually have 4 to 5 levels max, trophic levels I'm talking about, because the higher up you go in terms of the trophic levels, the less energy you will have. And eventually you reach a point where you don't have enough energy to sustain life anymore. What I'm trying to say here is that energy is moving in a linear direction, all right? However, when it comes to matter, matter is constantly being cycled. It's constantly being cycled and recycled, all right? It's constantly being used. Why is that? Let's take a look at our planet, okay? If we take a look at our planet, we will notice that Earth is considered a system, all right? And if you're not sure what a system is, what a system is, it is a structure that is made from other parts that work together to make it work, all right? So, for example, our bodies are systems because they are composed of organs that work together that keep us alive. A car is a system because it's made from, the parts like the motor and the wheels and the seats and the windows, etc. And all these parts come together to make the car move, and so on. So anything that is made from parts that help it work, we consider a system. Obviously, our whole planet is a very large system. And when we're talking about different components in this global ecosystem, these components are going to be, or basically this system is going to either be open or closed depending on what we're looking at. In terms of energy, our Earth is considered an open system. What does that mean? This means that sunlight, okay, or some energy, usually in the form of sunlight, enters into our planet, and some of that energy also escapes back into into space, or into the atmosphere, and then eventually into space. And thank God that happens, because if it didn't happen, guess what? Our planet would fry and we'd die. All right, and that's why global warming and climate change is a huge issue, because of the greenhouse gases. And I'm sure you learned about this last year. Greenhouse gases, too many of these greenhouse gases, is causing a thickening of the layer of the atmospheric ozone layer that is surrounding our planet. And essentially these greenhouse gases, because they are thickening, they are absorbing more and more heat, more and more energy, and not enough of this energy is bouncing back into space, which is causing our overall temperature of the planet to increase, right? So this is what we mean by open system. Some energy goes in, but then some energy also leaves. It's able to leave. It's open in terms of energy. However, in terms of matter, it is not an open system. Our planet is considered a closed system. What does that mean? This means that, let's look at one type of element that is essential for our existence, carbon. For example, in terms of carbon, whatever carbon is present in our planet is always going to be here, okay? It's not going to increase or decrease. We're not going to get carbon coming in from space, all right? We're not going to have any carbon entering from outside our planet, outside our system. The amount of carbon in our planet will always remain the same. The only thing that's happening is that it's getting recycled. It's getting recycled back and forth between biotic and abiotic factors, between a living thing and then back to the soil once they die, etc. So to summarize, in terms of energy, our ecosystem, our planet is considered an open system. And in terms of matter, it is considered a closed system, and matter can only be recycled. What do we mean by this term, matter is recycled, okay? This simply means that matter moves between the different spheres that we have on our planet, on our global ecosystem. And the 4 spheres are the hydrosphere, which includes all the water bodies on Earth, the oceans, the rivers, the ponds, etc. the atmosphere, which includes all the gases that surround our planet, okay, such as carbon dioxide, methane, sulfur dioxide, oxygen, water vapor. The geosphere, which includes all of the rocks and minerals and soil, etc., that make up our planet. And finally, the biosphere. And just from that word, you should know what that sphere includes, right? Biosphere, living things. Okay, so the biosphere includes all of the living things that live on our planet. So essentially, the matter here, carbon, nitrogen, sulfur, all of these elements that are necessary for our existence, which we refer to collectively as matter, it's getting recycled and it's moving between the biosphere and the hydrosphere and the geosphere and the atmosphere. And just like this picture is showing you, it's essentially a kind of like non-stop cycling between these different spheres of the matter. This picture is just a reminder of the energy pyramid that we saw last time, and you'll notice those orange arrows and the blue arrow. Okay, so the orange arrow is basically showing you that as these different or as the organisms that are found in these different trophic levels die off, their bodies get decomposed by decomposers. This is shown by the orange arrows. And then all of these nutrients, all of the matter that was stored in their body, carbon, nitrogen, oxygen, phosphorus, etc., all of those nutrients, all of that matter gets recycled back into the ecosystem, recycled back into the food chain or food web, all right? It never just disappears. Whatever enters into the soil is brought back into the ecosystem, is brought back into the food chain and food web. Specifically by either certain kinds of bacteria, which we'll talk about, or the plants themselves. The cycle that we're going to be covering today is the water cycle, and I'm not going to spend so much time on the water cycle because I'm sure you've done this in elementary, okay? So it's very straightforward, very simple. The water cycle essentially shows us how water, which is a very essential, I want to say mineral, is water a mineral? Substance, okay? Water, a very important substance. How does it move from one part of our ecosystem to the next? How come water is considered a renewable resource? In other words, how come water is does not end? We use a lot of water. Our planet has a lot of water, but there's a lot of us as well, and a lot of organisms, and they all use water. Why is water not considered non-renewable? It's actually a renewable resource, and that is because water is always being recycled by the water cycle. I have to make a side note here. Although water in general, so we're talking about the water that is found in the ocean, the water that is found in lakes and ponds and swamps, although this water is considered renewable, meaning it will never run out because of the water cycle, fresh drinking water that we can actually drink is scarce. So there isn't a lot of fresh drinking water in the world. That's an issue. We don't really feel this because we live in countries that are advanced enough to be able to take something like the salt water in our oceans, filter it, and then we can drink it. We don't even think about the fact that if we didn't have those technologies, if we didn't have that monetary money, monetary advances, we would be parched, right? We would not be able to have water, drinkable water. There are obviously many countries in the world, especially countries in Africa, where they are third world countries, extremely poor. They don't have enough money to have these technologies for filtering water, and for them, water is non-renewable. The fresh water they have is extremely rare, and if they do have any form of fresh water, a lot of the times they don't have the means, they don't have the money, the technology to be able to remove it, because a lot of fresh water is found underneath the ground. You have to drill to get it, and this creates issues, right? In terms of, we call it water scarcity. Not everywhere in the world is blessed with fresh water. Not everywhere in the world has enough money and technology to be able to have fresh water. So when I'm talking about here, when I'm saying water is recyclable and it never ends, I'm talking about water that is unusable. We can't really drink it, such as the ocean water. Okay, so let's go back to the water cycle now. The first step in the water cycle is evaporation, and this obviously happens because of the help of the sun. As the sun heats the surface of the oceans and lakes and streams, the water temperature gets hot enough. Those hydrogen bonds that were holding the water particles together break, and same with the covalent bonds eventually. And then water is able to turn into vapor. It evaporates, and as it moves further upwards into the atmosphere, it reaches an area where it gets cold enough up there where the water particles come back together. Okay, this is known as condensation. Essentially, when water particles come back together, they condense and they form clouds. After condensations, after those clouds have formed, when there's enough water particles in these clouds and they've become saturated with water particles, we see precipitation. And precipitation depends. Like, it doesn't have to be rain. It can be snow, sleet, hail. It really depends on the weather conditions and where you are in the world. So precipitation is essentially the water particles falling back into the ground. As rainfall happens, as precipitation happens, some of this water collects underneath the ground. This is known as groundwater. A lot of groundwater can be fresh drinking water, although the majority of it has to be filtered in order for it to be drinkable. Some of the water becomes surface runoff, meaning that it just kind of trickles down mountains and then eventually gets into streams and rivers, and the cycle continues. Now, another thing I forgot to mention is, in addition to evaporation being one of the main ways water particles turn into water vapor and escape into the atmosphere, another really main way of that happening is transpiration. And we already know what transpiration is, hopefully, from the plants unit. So transpiration, if you remember, is exactly the evaporation of water vapor from plants, or we refer to it as like plant sweating, right? So as transpiration happens, as evaporation happens, they return water or water vapor back into the atmosphere where the cycle continues. One thing we have to note is that the water cycle would not be able to happen without solar energy. So without the help of the sun, the water cycle would not be able to occur, because it is basically the first thing that gets it started with evaporation or transpiration. Okay, let's also look at this question. How is the water cycle related to the process of transpiration, which we know happens in plants? So to answer this question, we need to think about what transpiration is, right? So transpiration is the evaporation of water vapor from plants. How is this related to the water cycle? It allows water vapor to return into the atmosphere, where it then condenses into clouds, and then that turns into precipitation, which allows the water cycle to continue. All right, that is it for me today. So even though your slides have all the different cycles, we're covering one cycle per day just to not overwhelm you. So today we're just covering the water cycle, and then next class we're going to be covering the carbon, nitrogen. As usual, if you have any questions, please let me know, and I will be more than happy to help you out. Other than that, have a great day and see you next class.